Okay, now we'll do question 2, and we've been asked to sketch the graph of f of x equals x cubed plus 8x squared plus 11x minus 20 using the first and second derivatives. Well, the first thing I'm going to do, or did, was find the y-intercept by evaluating f of 0, which is negative 20. Now, let's find the derivative, and so f prime of x equals 3x squared plus 16x plus 11. Now let's set that equal to 0, and if we do that, set f of x equal to 0, because that's what we need to do in order to find the critical values, we get 3x squared plus 16x plus 11 equal to 0, and it turns out that this doesn't factor. So we're going to have to use the quadratic equation, which is x equals minus b plus or minus. So continuing on with this quadratic formula, plus or minus the square root of b squared minus 4ac all over 2a. And when I did that, and then I came up with a couple of irrational numbers, I rounded. And that's good enough. Round your answers. So I have the zeros, the critical values, x equals approximately negative 4.5 and negative 0.8. And so we'll put those on a number line, negative 4.5 and negative 0.8. And now we need to know whether the slope is positive or negative on this interval, and that interval. So we'll evaluate values in this value in this interval and see what we get for a slope. And if we look at f of 0, replacing f prime of 0, I beg your pardon, f prime of 0, we get a positive value, so that's greater than 0. So this is going to be positive. If we evaluate for a number in this interval like negative 2, f prime and negative 2, evaluating that, that'll be negative. That'll be positive, and so let's compute that. 3 times 4 is, because negative 2 squared is 4, 3 times 4 is 12 plus 11 is 23, but this will be negative 32, so that's less than 0. And finally, evaluating for a point in this interval like negative 10, that'll become negative 10 squared is 100, 300. Oh yes, that's going to be minus 160 plus 11. That's greater than 0. So anyhow, here's the signs indicate what our slopes are on those intervals. So we know what's going on there. Now, we have to find the y values for those points where these, and by the way, there's going to be a max here and a min here because we're greater than 0 that way, slopes climbing up and then climbing down. So let's look at f of negative 4.5, and what I get is 1.4, and f of negative 0.8, and this is an approximate value, and this approximately equals negative 24. So now we have a couple ordered pairs associated with these, and they are negative 4.5, 1.4, and negative 0.8, negative 24. Oh, I don't want a parenthesis there. Comma, negative 24. There's the comma. Okay. So now let's find the second derivative and check for concavity and for the inflection point. So f double prime of x, the derivative of this is going to equal 6x plus 16. And now let's evaluate f double prime of negative 4.5. And you can see by inspection, when we replace x with negative 4.5, the negative's going to dominate. So this will be less than 0. That means it's concave down, so we're at a max there at x equals negative 4.5. Let's evaluate f double prime of negative 0.8. And when we do that, the 16, letting x be negative 0.8, the 16, the positive, is going to dominate, and this is greater than 0, so we have a min at x equals negative 0.8. Now, let's set f double prime of x equal to 0 and see what the inflection point is. So that means 6x plus 16 equals 0. So 6x equals negative 16. X equals negative 16 over 6. So x equals negative 8 over 3. And when we evaluate f of negative 8 over 3, I came up with negative 11. So our inflection point occurs at negative 8/3, negative 11. Okay, we've got all this stuff assembled. Let's draw the graph. And we just need those points. And so here we go. We're going to draw the graph, and we're at negative 4.5, negative 0.8, and down here we're at 0 and negative 20. Let's see, our max occurs at negative 4.5 and 1.4. And we've got a min at negative 0.8 and negative 24, the y-coordinate. And the right end behavior is up because our leading coefficient is positive. So I think we can graph away. And that's what it looks like. And right here at negative 8 over 3, we have an inflection point at the ordered pair negative 8 over 3, negative 11. And let's see, x and y, and oh yes, notice on the slope to the right of negative 0.8 is positive. This is positive. Between negative 4.5 and negative 0.8 it's negative. This is negative, and we've got a positive slope to the left of negative 4.5, and we're done.